we are developing the first hybrid rocket engine to bring satellites into space, but with a very disruptive approach when it comes to the propulsion system. It doesn't usually explode. Candle wax, I think you never saw candles to explode.
You are building rockets powered by candleworks, and somehow that's not the craziest part of the story. From studying project to over 80 million euros raised, this is the story of HyImpulse.
Because you work for several years towards something, this launch, and then it happens, and then it fails, then of course this is a huge emotional problem, also emotional phase.
What do you think about the future of European space industry or European launcher industry?
Yeah, I think
space is humanity's greatest laboratory. Defense is democracy's strongest shield. And today, in workshops, in laboratories, in startups, a new generation rises, not to observe history, but to write it, where every innovation above drives progress below, where every breakthrough in defense preserves our freedom to create. Behind every breakthrough stands a founder with a story. Now these stories emerge to light the path for those who follow. Welcome to Rockets and Radars.
Kristen, welcome to Rockets and Radars. Before we actually get into your story of the company, I would love to get into a very simple question. In one sentence, what is HyImpulse for people that might not know you yet?
HyImpulse is a scale-up company that wants to deliver affordable launch services for small satellites with responsive rocket systems. But we are doing much more than launchers. Actually, we are a deep tech propulsion company because we are developing the first hybrid rocket engine to bring satellites into space. And we have also two other services or products, our suborbital rocket SR-35 and our orbital transfer vehicle HyMove. So we are full space mobility service basically, but with a very disruptive approach when it comes to the propulsion system.
Nice one. Good pitch. You have worked on it for some time. I can see here. Okay, great. And I also want to know the personal side of yours. So if you can tell us a bit, who is Christian when he's not building rockets?
Well, I'm a aerospace engineer, although I'm not doing that anymore a lot. I'm doing, of course, running a business, which is completely different. I'm a dad, and I have a black belt in karate. So
Wow.
I try to do also some sports, but this is probably the one thing next to family and company that is, taking up the least of my time right now. Unfortunately for my health, probably.
No, I think it's fortunately, but still, I didn't know about the karate part. So good to know. Good to know. Okay, let's get into the company story from the very beginning. Let's get back in time and let's get into a year 2012 when you're studying aerospace engineering at the University of Stuttgart. And there is this student team called HyEND that has been building hybrid rockets since 2006. And I want to understand, how did you even find those folks and what made you to join that group?
Yeah. So, well, actually, I could start even earlier. I grew up very close to the German Aerospace Center in Lampertshausen, which is known to be the largest test center for rocket engines in Europe, next to Vernon in France. So basically everyone in the space industry, at least in the launch industry, knows Lampertshausen, even if you go to the US. But people living around here not necessarily know about it. So it's really famous for this one thing. But when I was a child or then later a young student, let's say, people around me couldn't really explain me what's going on there, from something with rockets to launching rockets, which obviously in the middle of Germany doesn't make sense. Everything was told to me. And so I was very curious already as a child to learn more about it. And that led me to do internship there during my school time even. And that eventually made me study aerospace engineering, always with the idea to go back there to develop and test rocket engines. And so when I was at the university in 2012, I was basically searching for a student group to apply my knowledge, because I still think this is the best thing you can do at the university, to find an academic group and bring your skills to the application and not wait for the job to start with that. And Fortunately, I found this student group HyImpulse, like you said, hybrid engine development, that still exists today and is still, I would claim, the most successful student team when it comes to rockets in Europe, maybe even the world, because the student team still holds the world record for the highest flying rocket that is not just a solid rocket motor today. And I met my co-founders there. 2012, the group was pretty small, but I think 2 weeks after I joined, there was a big announcement that German Aerospace Center will give funding to the student group to build rockets to actually launch. Before that, there was just ground-based testing and development. And so we set out to break this world record back then by the TU Delft, who launched their Stratos 1 rocket to 12.5 kilometers. Then I think in 2014, they broke their record and brought it to 21 kilometers, and still we wanted to break that. And finally, in 2016, we were successful to achieve that. We launched then to 32.3 kilometers. And only 1.5 years ago, our successors broke this record, and now they launched to 64 kilometers, which for a hybrid rocket by students is really exceptional, building on the design we had almost 10 years ago now. And the specialty that we always did was we used paraffin as the fuel, because it's a really innovative solution for hybrid rocket engines. But it's also safe, which makes it quite attractive for students. So it doesn't usually explode. Candle wax, I think you never saw candles to explode. These advantages we still use as a company today. The low cost, the simplicity, the safety. But there I met my co-founders, and then we basically, after the successful launch, we said, okay, now we have to found a company. We have the right technology.
Yeah, and I will get into this story that you just mentioned even more in detail. And before we get into that, can you explain to the audience why this type of propulsion is so uncommon in the world? And why did you mess with this specific technology that everyone else had given up on, historically speaking?
Yeah. So actually, some of the first pioneers of rocketry were experimenting with hybrid rocket engines. Hybrid just means a hybrid between liquid and solid. So it's not like in cars where you have electric energy. It's really hybrid is a mix between liquid and solid propulsion. And liquid propulsion, of course, was after the Second World War really advanced a lot, because the goal was to go to the moon, build bigger rockets, and there were a wide variety of oxidizers and fuels available. So that was not an issue. And solid rockets, of course, were progressed because of the military application. So a lot of money, in today's terms, many, many billions, was spent over the last 70 years to advance this technology. And the hybrids back then, they had some initial success, but they used really strange fuels and really strange oxidizers that were not very practical and not safe, and especially toxic and difficult to handle. So that was basically the reason why hybrids were forgotten, except for a small group of researchers every now and then. But the promise of hybrids, that they are non-explosive, and that you actually can combine a lot of different propellants, that was still there. And so still researchers around the world were working on it all the time. And then only in 1997, there was a research group in Stanford University in the US who, so to speak, discovered that paraffin is a great fuel inside a hybrid rocket motor, because it solves some of the big issues they had. Because historically, the classical fuels like plastics or HTPB, which is a rubber that is also used in solid rocket motors, is burning very slowly in the hybrid rocket engine. And if it burns very slowly, you need very large surfaces. And that makes it either a very long engine or a very complicated engine. And so there was never a breakthrough until in 1997 they discovered paraffin melts, and suddenly inside the hybrid rocket engine, behaves like a liquid fuel. So you have the advantages of a solid fuel, which cannot explode and is already stored inside a chamber. So you don't need pipe or a valve or a pump. But it also has the advantages of a high performance, that it can burn quickly and that it behaves like a liquid fuel. And when the student group was founded in 2006, they looked at basically three things. It needed to be cheap because they didn't have a lot of money. It needed to be safe because they wanted to test on the university side first before later it moved to the German Aerospace Center. And the third point was it needed to be something innovative that has a promising outlook, also to do master thesis or a PhD maybe later. And so their survey concluded that for that 3 points, the hybrid rocket engines with paraffin as the fuel was the ideal candidate because it's non-explosive, it's very low cost to procure and manufacture and test. And it's also, back then in 2006, was completely new because just 10 years before the first people worked on it. And their choice turned out to be correct because all these advantages today are still valid and we are still making use of them and we are still using that system because of those reasons. So really great that almost 20 years ago they made the right decision that led to our journey of HyImpulse and our successes.
Thank you so much for packaging this story into just a few minutes. Thank you for giving us the context into what is coming up in the upcoming minutes. Just to understand, so you joined the student team around 2012, is that right?
Yeah.
Okay. And before you got into 2016, when your third successful rocket broke the world record, I want to understand how was a day-to-day life in that student group, and how were you moving through the first two rockets that you actually launched? I want to understand everything. What was going on through your head, and how did it look like inside?
Yeah, as a student group, you have a huge advantage. Labor is for free, and people are extremely motivated to work also for free. So we made very fast progress in the beginning, designing the rocket, testing the stuff. The difficulty in a student team is the continuity. You have always people joining and then leaving because they finish their studies, or some of them go abroad and so on. So this was a difficulty, but nevertheless, we very quickly made big progresses on the whole system because before that, before we received this funding and before the starting point of this project, we just did the engine part. And now we had to do the whole flight segment from the tanks, the structures, the recovery system, flight computers and software, but also the operational aspects of a launch, safety analysis and all of that. But the group grew in that time from 5 or 6 people to almost 20, and we managed all of that. And later the founding team of HyImpulse during that time already showed that we were kind of the core of this team and we were very naturally taking over the lead. And yeah, that was a lot of fun, of course. This time was very intense because in the same time we did our master, or back then diploma thesis, and later the PhD thesis all simultaneously. And then we did our first very small launches, well, very small, also a few kilometers high, in 2014 and 15. And then in 2015, we did the first launch campaign with a full-size Heros rocket, how we call it, which basically was intended to fly to 30 kilometers as well. But we had a failure during the flight. It just reached about 2 kilometers. And so we had to go back and build 2 more rockets, and luckily we got more funding, and then we were successful. So we were very resilient also for a student team. I think that's also very special.
With the Heroes 1 launch, how did it feel? What was going on through the heads of the team when you saw the combustion instability kill the launch, essentially?
Yeah, so we used back then a liquid oxidizer called nitrous oxide, laughing gas, and it's very sensitive to temperature. And in Kiruna, where we launched, is minus 20 degrees. And basically our temperature of the oxidizer was not properly set. It was too cold, and that's why the engine became unstable and it didn't work out well. With rockets, it's really different than a lot of other deep tech topics. You work towards one launch campaign, and then it's almost binary. Either it's a success or it's a failure. There's not a really gray zone. If you build a new type of car or other stuff that flies or moves around, then you can do small tests. You do a hop, and then you do a bigger hop, and then you do a bigger hop. With rocket, it's not really possible. You have a binary decision: do I launch or not? And then you have a binary outcome: was it a success or not? And because of that, because you work for several years towards something, this launch, and then it happens, and then it fails, then of course this is a huge emotional problem, also emotional phase where you have to go through all different emotions within the team, within yourself. You invested 4 years or 3 years of time into this, and then it didn't work. So there's also huge disappointment. But then, of course, it's why we're doing it is we want to launch rockets. We want to bring the European space industry forward. And so we did it again. And then finally it worked in the third attempt. And later we found out also the second attempt worked. We just didn't know it because we lost the data connection. So it was like we assumed it's lost, but actually it was not.
Actually, tell me more about the second launch. How was it different from the first one? You have had many learnings before that. If you can tell me
the
about
main
that.
learning was we need to bring more heaters to S range to heat up the nitrous oxide, and we did that. And then the nitrous oxide temperature was fine. We launched it, and then we lost it. And the reason we lost it is we didn't have the telemetry downlink, so we didn't know what happened during the flight. And we assumed everything has failed. And then we prepared the third launch, and we tried to find the root cause for this second failure. We thought we probably have found it. We did some testing on the avionics, and we launched the third one, and luckily it was successful. And then 3 years later, a hunter found our second rocket in the tundra there, or whatever it is, taiga, and it was intact. So it actually worked. We just didn't know, and we learned about it a few years later that it also worked.
As you mentioned many times, you have worked on this for several years. I can imagine people were doing masters, PhDs, right? Some people working also in their day-to-day job. What kept you coming back to this student group when people were doing all kinds of stuff? How did you keep the motivation up and running?
I think back then we had a completely different situation in the European space industry than today. Today you have HyImpulse, and you have 5, 6, 7, 8 other startups in this area. You have startups in other areas like in-space propulsion or OTVs. So there's a really growing and thriving new space industry with a lot of opportunities for students as an internship or working student or thesis. Back then it was different. If you wanted to do something hands-on, you had to really find the opportunity because you had Ariane and Vega, and that's it. Very difficult back then to reach, to get into those companies. And at university level, there were only a handful of student groups. So for us was really the only option, the best option to get hands-on experience. And we knew already that this is what we need because it's fun and it's the best training we could get as a student to develop really a project from scratch to the launch or actually even to the landing with the parachute. And so that was not a big discussion whether we would go or invest our time or go back there. It was always the best option for us to do it.
What do you think is the best option for other student groups like you were back then, right now in this current time?
I still think today is even more possible. You see how many student groups are now successfully launching rockets, whether it's hybrids or solids or even liquids now, because 3D printing has brought also a lot of innovation there that makes it for student teams affordable to build their own liquid rockets. And it's really inspiring to see how many different projects there are. We get so many requests to support all of these companies with our expertise in doing reviews or helping them produce stuff that we cannot even answer all of those requests because we are focused on our own development. That's really great. So right now, if you're a student and you want to do something hands-on, you have so many options. And then you, of course, have all these scale-up companies now that are offering their internship programs or theses. I think there has not been a time in the European history where we had more rocket engineers in Europe than right now. This is really
Oh, that's a great actually reflection. And by the way, for if there are any engineers that are still in the university listening, would you recommend them to start a similar initiative as you did back then through a student group, or would you instead recommend them to directly go and get an internship in, for example, HyImpulse or any other players?
Yeah, I would say both, because in an internship, you can of course learn from experienced engineers. You learn also how companies work, because a company will always be different than a student group, because you have to maintain quality control. You have processes, especially the larger the company gets. You need these processes even in a startup or scale-up company. But in a student group, you can do it yourself. You can lead it. You can learn, am I a good leader or not? Am I someone that wants to work on a specific topic, or do I want to have a broad overview over the whole development of a rocket engine or even a whole rocket? So I think to learn also more about you, what you want as an engineer, it's very important to do something in a student group where you get hands-on experience, but also responsibility. As an intern in a company, you will always have a limited responsibility, and that is also important to learn the skills, improve the skills, but it's not the same.
Very good advice. Thanks for sharing that. And before we get into the very start of your company, which is the most important one here in this journey, is the launch of the third rocket that you mentioned several times here. That was successful. You reached, as was said, 32,300 meters, which was a world record for student-built hybrid rockets. And you absolutely crushed it. That's no question there. But what I want to understand here, how did it feel after two failed attempts to actually reach that apogee number? I just want to know, like, what was going on through your heads?
Oh, this is, of course, a lot of emotions. Engineers are not always the strongest to show emotions, but we had a really good party back then. However, it also was then just the starting point. So very quickly we moved on to the question, okay, but what now? Our student time is over now. We did our PhDs or diplomas, and now let's think about what we can do next. And this was then more the topic that occupied our mind. But of course, the launch itself, and that is still today, a launch is a highly emotional event, especially if it's your first or one of the few ones you did. Also, I would say probably even for SpaceX people, every time they launch, even if it's 100 times a year, it's still every time exciting, I guess. But for us, surely it was.
By the way, what I want to understand, so since you broke the world record with Heroes 3 and founding HyImpulse, there was around 16-month gap. I want to understand what happened in that gap, why it did take you those amount of months to go from this works to let's start a company.
Well, first, like I said, I and my co-founder Mario and also the other two, we were still working at the German Aerospace Center and doing our PhD. So in the meantime, until 2019, I worked also on my PhD thesis.
Makes sense.
But we also did the switch then. So technologically, we decided, and okay, we want to found HyImpulse for several reasons. Firstly, because the technology fits ideally for smaller and medium-sized rockets, with less components, being cheaper and safer. And we saw, of course, the success of Rocket Lab in the US, where we said with our technology, we can actually be much more profitable than Rocket Lab ever will be with the liquid engines. Secondly, there was not really another option in Europe. So big agency representatives, big industry representatives, they were still saying, yeah, what SpaceX does, landing doesn't make sense, reusability, we have to be high quality and launching Ariane really reliable. All smaller satellites will be deployed with Vega and Ariane. And then, of course, 7-8 years later, we had the launcher crisis, which we are slowly getting out now. And so we had to found the company. So on the one hand, we had the best solution, we had a great team, and we have no other option in the space industry. And actually, as you know, we were not the only space and rocket engineers at that time that had exactly that feeling, because several companies were created in that time. And I think that was a pivotal moment in the European space industry, actually, starting.
No, I can
It was in
totally
2006.
agree with you here.
And then
And
we had to do one technical change also. So we said we have to launch satellites into space, and for that we need to switch from nitrous oxide to liquid oxygen. So what we also did in 2018 was to switch that and to do the first basic experiments on liquid oxygen and paraffin in a hybrid rocket engine, because in opposite to almost all the other rocket startups around the world that are doing small launchers, we have a completely new technology. We had to start with basic research, whereas everyone else, if they wanted, they could have bought an engine. Some of them did, or at least hire engineers who did it before. For hybrids, that especially with liquid oxygen, that was not possible, and we had to start with basic research.
Okay, super interesting. And before we get further in the story, I want to go back a bit and understand when you decided let's start a company. Was it a gradual decision process, or was there any catalyst that made you to turn the switch? Okay, let's go.
It was very gradual. Already in 2015, we decided, we talked about, okay, what can we do with this technology later on? Then there were people like SSC, so Swedish Space Corporation, who operated a launch site. They came in there and then saw the big rocket, and the first thing they said, okay, everyone drop all the tools, take a step back. This is not a student rocket. What are you doing here? This looks dangerous. Then we had to explain them, this is a hybrid rocket. It cannot explode. It's very safe. And then they slowly, okay, then maybe students are allowed to build something that big here. Okay. But they then also told us, okay, this what you do here is really innovative compared to what we're doing with solid rockets since many years. But nevertheless, every now and then there's a big accident with solids, sometimes even with casualties. And so they saw immediately this advantage. Then we got support from our professor at the University of Stuttgart in the German Aerospace Center, Lambertshausen, who said, okay, you guys have to do something about it. This is really a one-time chance in the history also of the DLR Lambertshausen. We were the first startup to spin off something there when it comes to rocket engines. Now there are further ideas as well. So it was a very gradual and talking to a lot of people, a lot of support from a lot of people. And then we took the decision, yeah, that's the right way to do it.
And I also want to understand, was there any big change internally if we compare the student team and working on those 3 rockets, and actually many more before that, and starting HyImpulse?
Of course, we had to learn. I would say in the first year of HyImpulse, we almost worked still the same way like in the student team. Like I said already, we naturally took the leadership of the student team, and the 4 founders then became also the leaders of the startup. So we just continued our roles. But of course, in the last 7 years, this changed. We have now middle managers, so to speak. We have a small, but we have a hierarchy. We have processes like quality control and all of that. And so this changes, of course, in a company over time as you become more mature, and you need to be able to grow even further. And you cannot do everything like uncoordinated, like in a student team.
And that was my next question in my head here. Is there anything you shouldn't do if you spin off from being just a student group into being a company? What is something that you shouldn't do that you did before as a student?
Yeah, we are 4 founders and we are 4 engineers. And that was a very good constellation. I would be cautious to have more than 4 founders. 4 is, I would say, the maximum. Maybe rather get another non-engineer on the team, like someone who knows about funding or someone who knows about sales, marketing. Of course, you can get this expertise later. And I must say, for engineers to understand, for example, everything related to numbers and finance is pretty easy to understand, at least on the top level. You don't need to know everything about the accounting, I guess. But other than that, I don't think I can tell about a lot of mistakes that we did. Yeah, I think everyone will find their own way. Yeah, no startup story is the same like the other. It's always individual stories, and yeah, I think just do it.
Yeah, very organic
Exactly.
transformation.
Yes. Yeah.
Okay, how did you kept yourself in check with finances that you nudged on? The first year you haven't got any external capital, if I got that right. So how were you powering the company actually from this perspective?
Yeah, we founded in the beginning of 2018 and started in the search for an investor. So actually pretty quickly, end of 18, we had our seed investor, then Professor Schwarz, who supported us until 24 to the first launch of our HyImpulse sounding rocket. And yeah, and then this was actually pretty smooth in the beginning. We had the luxury of having a part-time job still at the DLR, so we were not jobless at the time. I did still my PhD thesis in that time, so that's a pretty comfortable starting spot, to be honest. But the great thing is there are transfer programs like this everywhere now. So if you're at the university or at the German Aerospace Center or other research institutes, there are many options like this. So this is actually quite nice to use such programs. Then we had our seed investor, and we were able to build the company up with up to 50 employees in 24 and launch our first suborbital rocket then with liquid oxygen as the oxidizer.
And before Rudolf Schwartz entered the story, I want to again get into your head and try to understand how are you thinking about fundraising at that point. You were 4 engineers coming out of the academia. What were your options on the table that you were considering before you found Rudolf?
Yeah, so we back then talked, of course, to a few smaller VCs also here in the region, and that was not easy. So, of course,
Why?
rockets, it's difficult.
Oh yeah.
And we probably one mistake that we did was not to go to too many VCs in deep tech hubs like Munich or Berlin, but we rather used our existing network. And finally it worked. We found Professor Schwarz through that existing network. But it would have been nice probably to bring in also VC already at that early stage. That would have made the follow-up rounds potentially quicker. But in the end, like I said, every startup follows their own story. And for us was then pretty good because we were in this different position than a lot of competitors that we had to still do basic research. And the partnership with Professor Schwarz allowed us to do this basic research and take also a bit longer for the first launch attempt, although we were still pretty quick in first launch attempt compared to some others.
And if you remember, what convinced Rudolf to actually put his own money into you?
he was convinced that Europe needs a new way of doing space industry. Like I said, back then everyone was still saying, yeah, SpaceX reusability is not of concern. Ariane 5 back then and soon 6 and Vega are doing great. So there was a little bit of loss of reality maybe in the whole industry, or they didn't want to accept that maybe changes have to be done. But Professor Schwarz saw this, and he saw that okay, we need to do things in a new way. And then he also saw that our approach with low cost propulsion really can transform launch and access to space. And he understood that really quickly. He's an engineer as well. So we didn't have a problem to explain it to him. And that made the decision then actually pretty fast in the end.
Okay, great. And you nudged my next question, which is hiring. You mentioned 50, right? Was the number of folks that you got once you got into the. Oh, that's a significant number. Tell me how you think about getting new hires, especially the first 10, I think are the most crucial for start. How did you think about finding those hires, and how did you think about choosing the right ones for you?
The good thing was that back then we had, of course, already a few people in the student group that were interested to join, but we also had, because we were researchers at the DLR, we had also our own students that were doing internships or theses with us. And so the first hires actually came from this group of our network. So researchers or former students that joined us very quickly. So until we were like 10, 12 people, that was very smooth. And then we just started hiring by opening job descriptions. And even from the beginning, when we were not really known, we got a lot of applications. So back then, there was not a lot of options. If you wanted to be in the space industry, what could you do? Ariane was not hiring, Ariane Group. And the other startups were also very new, and we were also very new. And yet people applied, and we found really great people, and a lot of them are still with the company today.
And what is the top one priority that you are looking for in the hires that you actually got into your company?
I think there is not a top priority. I mean, people need to be excellent when it comes to their skills and understanding of their work field. Of course, we need also very high motivation. Yeah, startup usually pays a bit less in the beginning. However, we offer end-to-end involvement in the whole product and service development, something that in a larger corporation, of course, you don't see. Here you can bring your part, whatever it is, from the first idea on the drawing board to the flight of the rocket. That's something that usually in a big corporation, someone else will take over from you. And so that, of course, helps then to find people that want to see this whole thing and gives a lot of experience to them as well. So we never found it difficult to hire people in the first years. Now, when the company grows, we have, of course, other skill set that we are looking for. We need leaders, people with experience in a mix with people that are maybe coming fresh to the market. And now it's sometimes a bit more tricky to find exactly the role that we want. Probably our criteria, our requirements have also increased over the time, because as the company grows, things get more complicated and are not as easy as in a group of 20 people in the beginning.
No, precisely. But it's always good to have higher standards anyway in the
Yeah.
first start. Okay, great. And before we get into your SR-75 launch, we stay on the topic of funding. So you got over 2.5 million in soft funding from EU Horizons program, as well as from ESA through their Boost program.
Mhm.
And now I'll ask you, what is your approach in getting money from those sources? If you compare it to getting money from Rudolf, how were you thinking about achieving those financial milestones?
Yeah, I mean, of course, for public funding, there is more a formal way to get it. I mean, especially European project funding with the Horizon project, that was just, write the put application, which took not only one try. We tried, I think we won it on the third attempt. because you just need to have some keywords in the document somewhere that someone can tick a box and, okay, this is innovative enough, and then gets to the next phase. This is something you have to learn, and it's not always successful. But of course, we had always the luck that access to space was always on the political agenda very high up. Until the Chancellor's office in Germany or the Commissioner's office in Brussels, everyone is aware that this is the bottleneck that we need to solve. Especially when I said in 2017, there was still this, we will do everything with Ariane and Vega, but pretty quickly then, 18, 19, this changed already. So this was very fast that this changed, which...
Yeah, like a switch.
Yeah.
Pretty quickly. Uh-oh. Okay.
SpaceX was ramping up that launch rate and taking up all the market. Rocket Lab was doing well as well. And in Europe, there was like, okay, we know one delay for Ariane after another, which SpaceX had also always the same delays, but they were better in marketing them as not being normal or successful. But yeah, they were just doing things that we in Europe could only dream of. And so this changed rapidly. And so the public funding was actually then always searching options to invest in this field. And of course, we're happy that we won both European funding and also ESA contracts through the Boost program, which help us a lot then in return to raise also private further funding.
I want to keep it practical for listeners that might just started the process of getting the Horizon 2020 program. I'm curious if I can tap into your head and understand, what did you learn through those 3 iterations? You mentioned something around using the right keywords. What those are, actually?
Yeah, we actually found then some people in our network of, let's say, researchers that had won already a few contracts, and that helped us to polish our proposals. So you really have to learn how to write those proposals. It's not the most fun experience, but yeah, in the end, one thing that is really important is, as an engineer, you have to learn how to explain your work and your idea to different stakeholders in a different manner. The way how I explain it to potential investor, whether it's completely different, whether it's a VC or a strategic already. But then if I have to explain it to an authority, it's again completely different. I have to use a different language that they understand. And that's also true for these research proposals. You have to really learn how to do it or get advice on how to do it.
Again, organically learning over
Yeah.
time and failing and getting. Okay, great advice. Before we get into the SR-75 launch, I want to grab those couple of years before you got there. Do you have any big milestones that you remember, either the biggest learnings or anything that you remember right away in your head before you got into that milestone of launching in Australia?
Technically, of course, we had many ground test milestones in between. Our first large engine test at the DLR in 2020, then moving to our test site in Scotland for many years in 21, setting up a test site there, learning also about regulation and bureaucracy, something that student groups still can somehow maneuver through. They get a lot of exceptions, but once you're a company, there is no exception anymore. So things become more bureaucratic. And then, of course, learning that leading a company is leading a group of people, and that especially as a C-level, in a C-level role, suddenly leading a team and HR questions are taking up significant parts of your time, because you have to manage a group of people that has different problems. Sometimes it's private stuff that affects work. Sometimes it's communication issues at work, and these just need to be addressed. And it takes up a significant time, a part of your time in a company, to grow the team. And we had, of course, COVID. A lot of other companies had that, or all other companies had COVID as well. And that was not the most easy time to scale up a business. When
Not in rockets, right? Especially.
when everyone is at home and company culture in a startup and a scale up company is, of course, very important. And we had to invest time to maintain the culture also if everyone is in their home office. Now that's a bit easier again, luckily. And then other than that, of course, um, we had to build a rocket, which is complicated. So there are many small things that we had to attend and improve over the time. But eventually it worked out.
If time travel existed and you would be able to go back, what would you tell to younger Christian while
I would tell him
building?
all the secrets why which technical changes we had to do to make the locks and paraffin work, and of course to think about how to run a company, what it means from the beginning. But I think that's natural. You have to learn it, right? Of course, if you could take a shortcut, fine. But you can read as many books, you can talk to as many experienced people as you want. You have to experience everything yourself so that you can include it into your experience and then make decisions based on that experience. So
Yeah, what
there's
I like about your advice is the most tempting one. That you can read whatever you want, but you won't get it until you try it. So,
yeah,
pretty realistic and pretty
yeah,
straightforward.
yeah.
Okay, great. Let's now get into the launch of SR-75, which you had to launch from Australia. And please tell us, why did you had to go through the whole globe to actually launch your inaugural launch?
Yeah, spaceports are, of course, a limitation, especially back then. Nowadays, it gets better every year because more come online. So already in 2019, I believe, we started both discussions with Saxaford in UK and with Southern Launch in Australia, and progressed with both licensing and ground infrastructure and roles and responsibilities, both in UK and in Australia. And in the end, it was just a decision that Australia had all the infrastructure ready, whereas Saxaford was still in the building phase. Especially for a suborbital rocket, we need these launch rails. On the images, you will see this white construct, which is a launch rail, which the spaceport in Southern Launch in Australia, they built it and they had it, and so we could use it. That was the main part. The great thing about our rocket, because it's non-explosive and the paraffin is inert and safe, it was very easy to get the transport done and to also set up the rocket and the infrastructure on place. Actually, 3 weeks before the launch, there was just desert. And within 3 weeks, both the spaceport and us, we built up everything and launched the rocket and recovered and packed it. So after 3 weeks, we left already. So it was just 2.5 weeks until the launch, basically. So that it was pretty record time, and is also probably just possible because of our technology.
By the way, just a rhetorical question. When you were packing everything up and shipping it to Australia, did you describe your transporting a rocket, or you just say candleworks?
No, it was, we had also a export license because it's a dual
Okay,
use
fair point.
and all, so we did all properly. But if you explain that it's just paraffin and no non-explosive TNT equivalent, then it's very easy. The most dangerous goods were the batteries of our avionics.
Let's get into the launch day. T minus 10 seconds. You've been working hard for this moment since you were a student, 2002. That's plenty of years.
Yeah.
Walk me through those final seconds before SR-75 went up.
Yeah, so as I'm now as a CEO, not involved anymore in the day-to-day business, that's or in the operational business of the technology and the launch vehicles, I actually just was an observer in these last 10 seconds. So I didn't have a task to do. That was our CTO and our COO, so my co-founders Ulrich and Konstantin, who were operating the rocket and the ground infrastructure. So I was just yeah taking the 10 seconds to really look at the launch, experience it, and it was of course very exciting moment after back then 8 years to do finally a launch again. So it was pretty long time, and that was really exciting and a lot of fun to have this launch campaign there. And we're looking forward now to our next one because it remains exciting and fun. That's also part of why you are a rocket engineer, to have this experience.
And by the way, do I get it right? Were you the very first privately financed German company to successfully launch a rocket? Actually?
Yeah, yes, this was the first rocket that was, well, there is a funny story from the 80s. I recommend it to read about it because someone built some pipes together, filled it with propellants and launched it from Zaire in Africa. Funny story. That might have been also the first private rocket, but it was not as serious as our development. So ours was really the first rocket. From all the European startups, we did a pretty good job to launch within 6 years a completely new technology with very little capital. So some others did it also before us. PLD launched before us, but they took much more time and much more money. And then others, of course, launch now after us. ESA Aerospace launched last year. But like I said, they had not the R&D phase to develop really a completely new technology. But of course, they did already an orbital attempt, which we still have to do.
Okay, 6 years. And how much money spent?
It was about 15 million euros that we have raised until then, plus then the 2.5 million of the European Commission.
That's pretty cheap if you compare it to the industry standard even now.
Yeah.
So congratulations on that one. And what I want to understand, oh yeah, by the way, a funny story, the mission was called Light This Candle. We totally forgot to mention that. So very good. Congrats on the marketing as well. Very smart. So you have successfully launched, and I want to understand what it changed for the company. I guess the conversations with the investors totally turned around.
Yes.
After the de-risking went successfully. So tell me about what was the difference between you launched and after you launched.
So for us as rocket engineers already in the testing phase on ground, it was clear, okay, this will work at some point. It's just a question of when and how how quickly we can achieve it, because we can extrapolate from the ground data to the flight. Yeah, but for non-engineers, this is a different story. I can explain to people as many times, with candle wax, with paraffin, you can launch into space. And people will say, yeah, it's okay. But with that launch, that of course changed. People say, oh, it looks like a real rocket. I thought it's just paraffin. Yeah. Chemically, it's the same like kerosene. So that's why it can launch rockets into space. And that, of course, changed. And that showed that we are a serious contender for the best small launcher in Europe, the most affordable one. And we were able then to convince investors. And that's why we are happy to continue our work now with this recent Series A funding. And now we're working both on the next suborbital launch for next year and on our SL1 rocket for 27.
Tell us more about the Series A that you got in October 2025, right?
Yeah, that's when we announced it. It was a bit earlier in summer, but we raised 45 million in total, which was composed of public funding grants that were unlocked with the private equity that came in. And we are now actually doing an extension round in the coming months that will leverage it further so that we are well funded until the first or even the second attempt of SL1 launch. And now, of course, that is pretty pivotal moment in our company history. Now we are expanding a lot. We are hiring more people. We are setting up a new facility in the coming months. We have set up additional testing facilities as well in the last weeks. And we're looking really forward into a quite exciting time in the coming months.
So if there are any investors listening here, ring Christian.
There's
I will put
spots left, but not many, to be honest.
By the way, who you are looking for? Just a small filter for the ones that are listening.
Yeah, we are, of course, looking very broadly in the European, but also international investment markets. So there is not, I think we would not exclude anyone who is really interested. Of course, we're now looking mainly for investors who can do the larger tickets. Yeah, that is, of course, what is the most exciting for us, to bring on now investors that can not only do this extension round, but also follow through in the Series B and C potentially in the future.
Cool. So I will put a form so people can get in touch with you much quicker. And let's see if at least one investor gets in touch with you this way. Anyway, congrats on the round. And what I want to also understand, if you compare this specific type of fundraising with anything you have done before, what was the most different part? And would there be anything you would like to say to other founders that are about to raise a similar round as well? What to do, what to not do, or anything that comes to your mind?
Oh, that's very good question. I mean, we were very happy the way it went in the end now. So I would not necessarily want to change something. I think in the end, you have to speak the right language. Like I mentioned before, for investors also, you have to speak the right language. And of course, sometimes some external factors help as well. Like we had, of course, a great resonance also with political discussions in the last months, right? Space has really been recognized as a key industry, not only for
Fortunately.
defense, but also for the future prosperity of Europe. Because other industries like the automotive, they are maybe not anymore very important in 20, 30, 40 years. We will see. But for now, space will at least take a really important role in the future in Europe. And that is something that investors, of course, now recognize. And yeah, finally, I think just you have to be resilient and never give up, because it's not always easy, and no one will say immediately, "Here, take my money." They want to really understand if what we are doing is really good, and good is not enough. Actually, it has to be excellent, and we had convinced them that we are doing excellent stuff here at HyImpulse.
Great. And let's talk about the future. So you unveil something new apart from the next launcher, which you mentioned, SL1 orbital rocket, and that is HyMove, an orbital transfer
Mhm.
vehicle. How do you decide what to focus on right now and also in the future? Why are you already trying to build the next thing before the SL1 even launches?
Yeah, so like I said, initially, we have now become a space mobility company from suborbit to in orbit, with the major part, of course, access to orbit. We are focusing also on this point right now. So right now we are focusing on the commercialization of the suborbital rocket. That's why we do another flight next year. And we have other customers lined up to do further launches in the upcoming years. And then the second part is SL1, where we are focusing on right now. There are a lot of synergies with HyMove, our orbital transfer vehicle, because it has a lot of technologies that are necessary both on SL1 and on the OTV. So whenever it makes sense, we combine those efforts and continue it. But the HyMove team is a much smaller team right now than the SL1 or suborbital rocket team.
Got it. And where does Impulse go beyond that? Where do you see yourself within the global space industry?
Yeah.
I cannot say 10 years from now, but let's say as far as possible.
Yeah, I think 10 years from now is a good time frame. So we want to be able in 10 years to offer everyone a launch within a few weeks. Responsive space is a new type of service that we want to establish, not only for the military, but also for private customers, for companies that want to be able to launch frequently and quickly. Of course, now we have secured in Europe access to space again. We have Ariane 6 operational, and Vega is also doing well again. But is it really great access to space when it's booked for the next 2-3 years? I want to be able in the future that someone gives me a call and says, I want to launch in 2 weeks. Can you do it? And I will be able to say yes, because then we have a free logistics into space. And HyImpulse alone maybe cannot even do it. It needs several players, big rockets, smaller rockets, hybrid rockets, liquid rockets. To be able to have this kind of thriving space industry, we need to have a thriving access to space sector. And so in 10 years from now, I want to be able to offer this, so that if you call in 10 years, and I will be able to launch your satellite within a few weeks rather than 2 years from now. And that, of course, will then enable us with the OTV to be a full space company, which probably will not stop with mobility in space. But when you have the mobility, you can offer services and in the end become a satellite operator yourself or offer satellite as a service, which I believe is a very strong case as well, that in the future, everyone who wants to start a business with a very low initial investment can have their instrument or their system in space, not without building their own satellite. That is really what we want to become. And of course, in the atmospheric rockets, which is the suborbital rocket, we want to be the go-to company if you want to launch something for research or testing purposes. So flying test bed is what we want to be in the suborbital.
And beyond your future, I would love to ask you, what do you think about the future of European space industry or European launcher industry? We have nudged into that in the past, and I want to see, how do you see it evolving?
Yeah, I think we are on a great path, but we have still a lot of things to do and catch up with. If I compare it to 10 years ago, when there was basically no option visible whatsoever other than continuing the old stuff and the old way of working, this has changed completely. And of course, new companies like HyImpulse and other scale-ups and startups, they not only bring something themselves, they change also the existing players. So in Germany, we have the so-called New Space Initiative, where initially there was just the startups inside. Now every space company in Germany is part of it, and everyone thinks about how can I do things newly in my big corporation. So this actually created a change that will show its effects in the next 5 to 10 years. I think we will really see a commercialization, which is stepwise. Even in the US, space is not fully commercial. It will never be. The government will always be an important customer. But then how do you implement the systems and missions is the question. Do you have really the government say what they want to do for every step? Or does the government just place contracts as an anchor customer, and the industry finds the best way in the market to fulfill these needs? And that is what is happening already now. So I think we will see a very strong European industry in the future, because we have the talent, we have the supply chains, and we have the technology. What we need more is competition. Also, that is happening slowly. Of course, what we have in comparison to the US or even China is this competition between nations, and that will always be there. If we make it that we can turn this into something positive, that it doesn't become only competition between nations, but really between companies and solutions, it can be an advantage. So I think we have a good future, but we have a lot to catch up in the next 2, 3, 5 years. We have to mainly work on that we don't lose or that the gap doesn't get bigger. And then maybe in the 30s, we can start catching up.
And what about consolidation? You mentioned that there are new players popping up. Just in Germany, we have RFA, ISAR, and yourself. And then we have other players across the continent as well. Do you think that those players will consolidate in one way or another? Or do you think that every launcher company has their own spot within the local industry?
I think it will be a mix. So definitely there will be more than one company, especially I'm quite confident that there is a place for HyImpulse, because we have the only unique technology, where there's a place for 7 different liquid rocket companies that do all the same. I'm not so sure. I think there might be some consolidation. There are, of course, also new players still entering the market with ideas to build bigger rockets or smaller rockets, and we will see how that works out. Right now, I would not recommend to found another rocket company in Europe. I think right now is not a good timing for that. Maybe in 10, 15 years, it will look different again. So I think there will be a mix of finding market niches, finding different use cases for the technology that each company has, and also consolidation. How that will look like, I don't know. We will see that in the next years. However, that was already what we said 5 years ago, and we are still all here because there is so much need for access to space. So we will see.
But do you see our future optimistic?
Yeah, of
If I
course.
could. Okay, amazing, super. Thank you so much for sharing our journey and insight. It has been a journey for sure. Now I have my last section of this episode. I have a few prepared questions I would love to you talk about that are not necessarily connected to the journey, but I want to hear your thoughts on that.
Okay.
So let's get into those. What is the most painful rejection you have ever faced by building HyImpulse?
There have been some investors that reject us for simply saying like, yeah, what you're doing is requiring too much capital, which I think is a very stupid way of saying we are not interested at the moment.
What would be your argument now to them after what you've been going through?
That we are actually very capital efficient, but of course, if you want to build amazing things, big things, then it also requires capital.
Okay, got it. I hope they listen here. Anyway, next one. Germany has 3 companies racing to RBU, ISAR, and RFA. Do you ever talk to each other, or is it pure competition? I don't want to talk with you.
No, we talk to each other. We also sometimes do joint statements, for example, because we also have all the same interest to level up the European and the German space industry.
Okay, awesome. You left DLR, a stable job, to start a rocket company. Do your former colleagues think you are brilliant or insane when you got into
them?
What do you think?
Yeah, I think most of them are happy that we have a startup coming out of DLR Lambertshausen. But yeah, some people prefer a steady job at the German Aerospace Center and some people don't. So I think there is room for everyone and everyone can follow their own career dream.
Okay, good answer. If you can reflect over the last decade, more than a decade of being in this industry, what do you think is the biggest mistake you would love to warn other space founders about from your journey?
Learn early on about how the VC world works. That is probably the biggest thing that I would do if I could go back to 2015 or 16.
And how do you learn how VC works?
Yeah, probably
Apart from trying it out.
speak to more VC people initially, or make your first pitch, so to speak.
Okay, good one. And if there is one thing that the listener should take in from this episode, what would it be for our community? Space founders, engineers that want to become space founders, anybody in this industry. Yeah.
I think if you have a great idea, then there's definitely room in Europe to do this and follow your dream or your idea. And you just have to get started because initially there will be people who say it's impossible or no one needs it. Unfortunately, in Europe, we are very risk averse still as a society. So it's very normal to say, don't do it, it's too risky. And so if you have an idea, you really just have to start doing it.
Okay, awesome. Thank you so much for sharing this one. And again, thank you so much for spending 1 hour with me. It has been so much fun. So thank you so much, Christian, for this. It has been a journey.